Okay, so today we're going to start chapter 12. We are going to learn about some conic sections in this chapter, and we're going to start with parabolas today, and we're also going to do a little bit of circles. But I want to remind you what a conic section is. So what a conic section is, it's a picture. This is geometry we want to think about here. If you have what's called a double napped cone, which is essentially a cone and then the exact mirror image of the cone, but this is three-dimensional. And you want to think of this cone not as actually ending here, but instead as extending forever, infinitely in either direction. And so it's this kind of three-dimensional, forever extending cone. Okay, so if I take a plane and I chop and it's like a knife and I cut through this double napped cone, then what kind of result can I get? Well, if you cut through at an angle that's not very steep, one thing that you can get is this shape right here, which is an ellipse. And so one of the things we're going to study is an ellipse. If, however, you cut through at a little bit of a steeper angle, then you're going to hit here like this, and then that's going to extend forever in both directions, and that would be a parabola. And then also, if you cut it vertically, just straight down, then you're going to have this part up here that extends forever, and then you're also going to have the same exact kind of part in the opposite cone, and that is what is called a hyperbola. A hyperbola. And then finally, if you cut it straight across, but you're still going through this blue meaty part here, but not like the ellipse where you cut it at a bit of an angle, but if you cut it straight across, then you could also get a circle. Okay, and those are what we call the conic sections, these four items. We're going to study all four of them. There are also degenerate conics, and that's they're kind of like well, just particulars. Like if I cut through right here, then I would have just a point. Also, you can cut through, if I cut through just right here, right at the edge of this cone, so that it's tangent to each cone, then that would give you just a line. Or if I cut through it completely vertically through the cones in half, that would get you two intersecting lines. So those are degenerate conics, and those are conic sections, but we're going to focus more on the other four. Okay, so for circles, I'm just going to remind you what the standard equation for a circle is, and that would be x minus h quantity squared plus y minus k quantity squared equals r squared, where the center of your cone has x coordinate h and y coordinate k, and the radius is r. So if I go out r and make a circle. So that's the general or standard equation for a circle. Okay, what we're really going to focus on today is a parabola. Okay, the definition of a parabola is the set of all points equidistant from a line and a point not on that line. This line is called the directrix, and the point not on the line is called the focus. Okay, and so I'm going to just give you two basic examples of parabolas. These are parabolas that you can already graph. And then I'm going to talk about where the focus and the directrix would be. So y equals 4x squared is just a really skinny parabola that opens up. The vertex will be at 0, 0. I'd have coordinate 1, 4 and negative 1, 4. I'd have all these points on here. Okay, so the focus, and I don't know the coordinate of the focus exactly, we are going to find that out today, would be here, and the directrix is going to be here. And so the way this works is if you look at any point on the parabola, then this distance is the same as that distance. Although the way I've drawn it, it does not look the same. Okay, and actually I will tell you what the focus, where the focus and the directrix are, because I do know what that is here. Let me make sure. Actually, I'm not gonna tell you the coordinates of those just yet. We're gonna go over. I thought it would be simple, but this is not a nice example, so it's not. Okay, so in example 2 here, I have 2x equals 4y, or x equals 4y squared, and this is a parabola that instead of, notice this is different. So here I have y equals 4x squared, and so y is a function of x. But over here in example 2, I've switched x and y. And the way that we can graph this is you can just switch all of the x and y coordinates. So 0, 0 would switch to 0, 0. And this point here, which was 1, 4, will switch to 4, 1. And negative 1, 4 will switch to 4, negative 1. And so this is a parabola that opens to the right. And so in this section, we're going to have to graph parabolas that open up or down or right or left. All right, so this is review. These are things we've done before. So here are some important features that I want you to know about parabolas. I want you to be able to find the axis of symmetry. The axis of symmetry is always x equals h. The line, well, it's either x equals h or y equals k. The line that runs through the parabola that contains the vertex. Everything else around the parabola is symmetric over that line. I want you to know the directrix. Okay, so the directrix we're going to figure out based on the equation of the line, or the equation of the parabola, and putting it in standard form. Also the vertex. The vertex is going to be HK. And be able to graph it, and then also to find the focus. You can find all of this information if you understand the standard equation of a parabola. So here's the standard equation of a parabola. It is going to be one of two things. Either y minus k equals y minus k squared equals 4p times x minus h. And this would be an equation of a parabola that opens left or right. Or you could have a parabola that opens up or down, and in that case you have the x squared. And so here we would have x minus h squared equals 4p times y minus k. And so this one opens either up or down. Okay, whether your parabola opens in the positive direction or the negative direction depends on p. So p is everything here. Okay, when p is positive, then you open in the positive direction. Positive direction would be right or up. And vice versa, the negative direction would give you left or down. It would be left or down, and that will be if p is negative. Okay, so the vertex is always hidden here inside of the y or the x that's in parentheses, and you always minus those. So be careful. This minus means it's the opposite of the number that you see in there. And then p is really important. Not only does p tell you whether you're opening up and down or left and right, up versus down or left versus right, but p also tells you the distance between the vertex and the focus, and the vertex and the directrix. So p equals the distance between focus, vertex, same thing as the distance between the directrix and the vertex. Okay, and so there are formulas that you can use to memorize, but I only want you to know these things. I only want you to know the standard form and the fact that p tells you that difference, and then, or that distance, and then I want you to graph it every time and just look at the graph. If you can graph these, then you can read everything from the graph. It's really, really easy. So you just have to understand the standard equation and then be able to graph it, and then you can answer all of these important features. I will ask you any and all of these. Okay, so let's do it. Here I have an example. So let's look at A. If you look at A, x is squared and y is not. So because x is squared, this tells me that I have up down. So now I'm going to make sure that I'm in standard form, in which x minus h squared equals 4p y minus k. And now based on that, the very first thing I'm going to find is the vertex. So the vertex is hk. So that's what you take away from x, which that would be negative 3 here, and then what you take away from y, which would be 1. So my vertex is negative 3, 1. The next thing you're going to do is match up your 4p with your coefficient, because that tells you p, and you need to know p. So 4p is 4 in this case, and p is 1. So 1 is the distance between your vertex and focus and your vertex and directrix. At this point, I'm now going to work on the graph and and answer the rest of the questions. Okay. So, oh, by the way, am I up or down? I am up because P is positive. So I'm going to open up. And my vertex is negative 3, 1. I'm going to go negative 3, 1. Here's my vertex. And I know I open up. So I'm just going to even write that much. Now, let's talk about what the focus should be and what the directrix should be. The focus is always inside the parabola. And so I'm going to go ahead and put that green vertex, or that green point in there. And I know that since P is 1, this distance between my vertex and my focus is 1. And so if my vertex is the coordinate negative 3 comma 1, then what should my focus be? It should have the same x coordinate, but I just go up 1 to 2. And so we've got one of the questions answered. Focus is negative 3, 2. Now let's talk about the directrix. The directrix is always the line that lies on the opposite side of the parabola, because remember, a parabola is all the points equidistant between the focus and the line. And so the vertex, by the way, has to be then 1 away from the directrix also, because it's a point on the parabola. So this point is 1 away from both the focus and the directrix. And so if this line here, which is horizontal, so that means it's a y equals, is just 1 below the point negative 3, 1, then that means it lies where y is 0, and so it's the line y equals 0. And so this is my directrix. My directrix. Okay, then you also need to know the axis of symmetry. The axis of symmetry is the line over which the parabola is a mirror. It's the axis of symmetry. And so it is always a coordinate of the vertex. It's either x equals or y equals. In this case, it's x equals because it's the vertical line. So the axis of symmetry is the vertical line, x equals negative 3. All right, did I answer all of the questions? Vertex, focus, directrix, and sketch the graph. So I also found the axis of symmetry. I didn't need it. Okay, so that's it. Now we're done. Now let's work on B. Now, for B, it's important to note that I am not in standard form, and I did all of this based on standard form. So your first step here is to put this equation into standard form. And how do I do that? Well, first of all, these things need to be on opposite sides of the equation. Your y's and your x's need to be on opposite sides. Secondly, for the variable that's squared, which in this case is y, since y is squared, by the way, I already know that this is a left-right. I'm supposed to have it pretty in parentheses with a quantity squared. That's called completing the square. If I'm not pretty here, if I have an ax squared plus by, or ay squared plus by, I need to figure out how to factor it perfectly. And so that's called completing the square. And we've gone over this before. It's just a matter of remembering. I always say that there's a magic number that you add to both sides. And that magic number is b over 2 squared. This also only works if your a is a 1. So if otherwise it won't work. So if this if you had a multiple in front of the y squared, we would have to divide that out first, but we don't, so we're good. So here my magic number will be negative 4 over 2 quantity squared. So that's negative 2 squared, which is 4. And what you do with that magic number is you add it to both sides of the equation. So I have y squared minus 4y. I'm going to add in 4. And on the right side, 4x, I'm going to add 4. Now this left side will factor as a perfect square. It will be y minus 2 quantity squared. And on the right side, notice that the x has a coefficient. Anytime that x has a coefficient, you have to factor that out just to make it look like the standard form. And now I'm in standard form because I've completed the square and factored that 4 out. Remember, standard form in this case is y minus k squared equals 4px minus h. K is the letter we use with y, and h is the letter we use with x, and that's always going to be the same. Okay, so what's my vertex? Well, my vertex is always h comma k, and so the x coordinate will be negative 4, and the y coordinate will be 2. So my vertex is 4, negative 2. Now let's match up and find that p, who's the distance between the vertex and the focus, or the vertex and the directrix. So again, I made this up nicely. P is going to equal 1. Now I'm going to go to the graph, and from the graph it will be easier to determine what the focus is and what the directrix is. So, by the way, is this, I know it's a right-left. Is it right or left? Well, if you look at P, P is positive, so that means it's the right. So let's see here. Negative 4, 2. 1, 2, 3. And I'm opening to the right. So I'm just going to sketch that in there. P is 1, so I need to go right 1. I need to put my focus, which is always inside the parabola, at a distance of 1 away from the vertex. So if the vertex was negative 4, 2, then my focus is going to have an x coordinate of just negative 3, but that same height y coordinate. And then the directrix is going to be the line behind the parabola on the opposite side of the vertex. And it should also be this, whatever this p amount is, it should be that distance back from the vertex. And so the directrix is a vertical line this time, and so that's x equals, and this x coordinate is now going to be negative 5 because it's back 1 from negative 4. And then we're done. Okay, so now we're going to go backwards here. Now I'm going to have the information about the parabola, and I need to write the equation for the parabola. I'm going to do the same thing I did, but just backwards, but I start with the graph because that helps me a lot. The vertex is at the origin. The origin is 0, 0. So I know that my vertex is 0, 0, so that's the HK. It opens to the left. Oh, that's nice. All right, so then if it opens to the left, that means I know I have x minus, nope, I have y squared, not x squared. So I have y minus k squared equals 4px minus h. So I have these standard forms memorized. You're going to need to do that. And I can go ahead and fill in my hk. Those are both 0. So y squared equals 4px. Now the only thing left to do is figure out p. Okay, well it tells me that I contain the point negative 2, 6. So that's actually easy. I just need to plug in negative 2 for x and 6 for y. And if I do that here, then I can just solve for p. Now p should be negative since I opened to the left. And if you follow this all the way out, it is going to be negative. So p is 36 over negative 8, which is 4 goes into both of those. 2, 9 halves. So p is negative 9 halves. So that means y squared equals negative 9 halves x. Okay, and then you're done. All right, my next example is the one where you really need the graph. And so I'm going to do 5A. I'm going to have you do 5B. So my vertex is 3, 1. And the directrix is 3.25. Oh, great. That's 3 and 1/4. So that's 13/4. But that is a horizontal line, 3 and 13/4 this way. So there's my directrix. Wait, is that right? No, too high up. Let me move that down. 3 1/4 down, or 3 1/4. Okay, so based on knowing the vertex and where the directrix is, I know that I have to open down because the parabola folds away from the directrix, and so the focus is going to be inside the parabola here somewhere. But now that I know that I open up or down, I know that my standard form has to be something where x is squared. So it has to be x minus h squared equals 4py minus k. And my p should be negative since I opened down. Okay, let's go ahead and fill in hk since I know that. What was that? 3, 1. So x minus 3 squared equals 4py minus 1. All right, so what is this distance? Because that's going to tell me what p is. So this distance here is p. This is the point where y is 1, and this is the place where y is 3 1/4 or 13/4. And so to find that distance, I just need to subtract 1 from 13/4. That gives me 9/4. And so p is 9/4. So all I need to do now is plug in 9/4 for p. And that's going to simplify nicely. So my equation in standard form is x minus 3 squared equals 9 times y minus 1. And I'm all done. Now you all, I would like for you to do this one in which the focus is at 2, 2, and the directrix is at x equals negative 2. Now the vertex, remember, I didn't give you any information about the vertex here, and you have to figure that out. When you do that, you need to do that by graphing. X equals negative 2 is this vertical line. So this is my focus, and this is my directrix. Where should the vertex be, and how should it open? I want you to think about that. Once you know where the vertex should be, by the way, it should be halfway between. You can figure out that exact coordinate and figure out the standard form. Okay, we're going to pause here. You can stop with that last question, and we're going to do part 2 tomorrow.